Welcome to second class in variational method. In this class, we will discuss the ground state of helium atom. So as discussed in the last class, the main idea of variational method is to find the expectation value of the Hamiltonian operator with respect to a trial wave function. So this is the important factor. We should have a trial wave function. With respect to that trial wave function, we are finding the expectation value of Hamiltonian, and that expectation value is minimized by using variational technique. So the minimum value of that expectational value is taken as the possible ground state energy. So here the ground state energy will be always less than or equal to the expectation value of Hamiltonian. This is the main principle behind variational method. So here the problem is discuss the ground state of helium atom with the variational method. And for comparison, we will find the ground state energy of helium atom by time independent perturbation theory also. Then first of all, we will discuss the helium atom in terms of variational method. So in helium atom, there are two electrons. In the case of hydrogen atom, there is only one electron, but here there are two electrons. So the difference is these two electrons will be interacting with the nucleus. At the same time, they will be interacting with each other. So there will be inter-electron interaction. So our aim is to calculate the ground state energy of this helium atom. And physically, it is the energy required to strip off both electrons. That is, ground state energy means the energy required to ionize the helium atom completely. That is, to remove the two electrons. Experimentally, this value is found to be minus 78.975 electron volt. This is the experimental value of the ground state energy of helium atom. So we have to reproduce this number by using variational method, and then we will be reproducing this number by using time independent perturbation theory. So this is the number that we want to reproduce. So remember that this problem is not exactly solvable because due to the electron-electron repulsion, the electrons in the helium atom, the two electrons in the helium atom will be repelling with each other. So this repulsion makes the problem not exactly solvable. So Hamiltonian of the system is the Hamiltonian of two electrons at R1 and R2. So the Hamiltonian of this system is the Hamiltonian of two electrons. The position of electrons are at R1 and R2. So the Hamiltonian can be written as minus h cross square by 2m into del square becomes del 1 square plus del 2 square minus ze minus ze into e by 4 pi epsilon 0. Here z will be 2 because 2 is the atomic number of helium atom. There are two protons in the nucleus of helium atom, and one for each electron there is a negative charge minus e. So it becomes 2e into minus e, that is minus 2e square. So it is minus e square by 4 pi epsilon 0 into 2 by r1 plus 2 by r2 for one electron. This is for the second electron. Plus this is the interaction term of electron with the nucleus, and along with that there is electron-electron interaction. That electron-electron interaction will be 1 by 4 pi epsilon 0 minus e into minus e divided by the distance between them. So minus e into minus e becomes plus e square. So this term is the electron-electron interaction. So this problem is complicated only due to the presence of this electron-electron interaction term. If this term is absent, then the problem becomes exactly solvable. So if we ignore the electron-electron term, the Hamiltonian splits into two independent hydrogen-like Hamiltonians. That is, there are two independent electrons. They are interacting with a nucleus having a charge 2e. That is, the only difference is 2e instead of e as the nuclear charge in hydrogen atom. So this is called a hydrogen-like atom. Then the exact solution of the ground state will be psi 0 will be equal to psi 100 of first electron plus psi 100 of second electron into, that is psi 100 of first electron into psi 100 of second electron. So this is the product of two independent wave functions. It will be the total wave function. So for hydrogen-like atom, psi 100 is 1 by root pi z by a0 raised to 3 by 2 into e raised to minus z r by a0. Now, in the first step, we are going to calculate the ground state energy of hydrogen atom if we ignore the electron-electron interaction completely. So in that case, psi 0 becomes z cube by pi a0 cube, because this is this, it becomes psi 100 into psi 100. So this becomes 1 by pi, and this becomes z cube by a0 cube into e raised to z by a0 into r1 plus r2 for r1 and r1 plus r2. Now the ground state energy will be E0 will be equal to the ground state energy of first electron plus the ground state energy of second electron. Each electron is present in a hydrogen-like atom. Hydrogen-like atom എന്ന് പറഞ്ഞാൽ മീനിങ് ഇവിടെ ഈ ഹീലിയം ആറ്റത്തിന്റെ ന്യൂക്ലിയസിന്റെ ചാർജ് 2e ആണുള്ളത്. ഹൈഡ്രജൻ ആറ്റം ആണെങ്കിൽ e ആണ് വരുന്നുണ്ടാവുക. അത് മാത്രമേ ഡിഫറൻസ് ഉള്ളൂ. ബാക്കിയുള്ളത് ഓരോ ഇലക്ട്രോണും ഇൻഡിപെൻഡന്റ് ആയിട്ട് ന്യൂക്ലിയസുമായിട്ട് ഇന്ററാക്ട് ചെയ്യണം. അപ്പോൾ ഒന്നാമത്തെ ഇലക്ട്രോണിന്റെ എനർജി z² E1 ആവും, രണ്ടാമത്തെ ഇലക്ട്രോണിന്റെ എനർജി z² E1 തന്നെ വരുന്നുണ്ടാവും. വേർ E1 ഈസ് ദ ഗ്രൗണ്ട് സ്റ്റേറ്റ് എനർജി ഓഫ് ഹൈഡ്രജൻ ആറ്റം. E1 എന്നുള്ളത് -13.6 ഇലക്ട്രോൺ വോൾട്ട് ആണ്. ഇവിടെ കിട്ടുന്നത് E0 എന്നുള്ളത് ഇറ്റ് ഈസ് 2z² E1 എന്ന് വരും. സോ വി ഗെറ്റ് 2 into 2² into -13.6, that is -109 electron volt. So this energy, this is the ground state energy of helium atom if we ignore the electron-electron repulsion completely, but this energy is far away from the experimental value of -78 electron volt. So the electron-electron interaction is important, it cannot be neglected. Now we are going to discuss the problem with respect to the variational method. For variational method, as previously stated, we want a trial wave function. So what will be the trial wave function here? Here the trial wave function is, we will take this psi 0 as the trial wave function. That is, this psi 0 will be taken as the trial wave function with z as a parameter. And we want to make a term as a parameter, and the energy obtained will be minimized with respect to the variation in that parameter, and the minimum value of energy is taken. That is the principle of variational method. So here z is taken as adjustable parameter. The logic is, we can see that the electrons are interacting with the nucleus. The nucleus has a charge 2e. But due to the screening effect of other electron means for one electron there are two electrons. So if we consider one electron, the second electron partly screens the first electron from the nucleus, which is called a screening effect. So the effective nuclear charge felt by one electron will not be equal to 2e. Instead, we take it as Ze, where Z is a parameter, it may not be equal to 2. So we rewrite the Hamiltonian as -h² by 2m into del 1 square, and the second term was -2e² by 4 pi epsilon 0 r1. This was the second term. So now we are going to add a term -ze² by 4 pi epsilon 0 r1, and subtract the same term, that is plus ze² by 4 pi epsilon 0 r1. So these two terms cancel each other, and another -ze² by 4 pi epsilon 0 r2 and plus ze² by 4 pi epsilon 0 r2. These two terms are also equal and opposite, and then remains the original terms in the Hamiltonian, that is this Hamiltonian. This is the original Hamiltonian. The same expression is written here, but we are adding two equal and opposite terms. Then the inter-electron, that is electron-electron repulsion term. So that H is equal to minus h cos square by 2m into del 1 square minus z e square by 4 pi epsilon 0 r1 plus this term plus here z minus 2 into e square by 4 pi epsilon 0 r1, here z minus 2 into e square by 4 pi epsilon 0 r2. So we can take z minus 2 e square by 4 pi epsilon 0 outside. So the remaining will be 1 by r1 plus 1 by r2 plus electron repulsion. Now, so this is the Hamiltonian of the helium atom. Now in the next step we find the expectation value of energy. Expectation value E is equal to, with respect to the trial wave function psi 0, psi 0, h psi 0. So the first two terms, where psi 0 is the trial wave function, which is the wave function of a hydrogen-like atom with nuclear charge Z. So this term, that is minus h cross square by 2m into del 1 square z e square by 4 pi epsilon 0 r1 is the Hamiltonian of one electron, and this is the Hamiltonian of the second electron in a hydrogen-like atom. So the expectation value of these two terms are z square E1 and z square E1. So they will give z square E1 plus z square E1 plus. Then the next term z minus 2 e square by 4 pi epsilon 0 into expectation value of 1 by r1 plus 1 by r2. That is expectation value of 1 by r1 plus 1 by r2 with respect to psi 0 plus e square by 4 pi epsilon 0 into expectation value of 1 by r1 minus r2. Now for hydrogen-like atom, expectation value of 1 by r is z by a. Remember, for hydrogen atom, expectation value of 1 by r is 1 by a. For hydrogen-like atom, it is z by a. And for hydrogen-like atom, 1 by r1 minus r2. The expectation value of 1 by r1 minus r2 is 5z by 8a. So the energy becomes 2z e square e1 plus z minus 2 into e square by 4 pi epsilon 0 into this one becomes z by a plus z by a, that is 2z by a, 2z by a plus this one becomes 5z by 8a into e square by 4 pi epsilon 0, that is equal to 2z square e1 into 2z into z minus 2 into, this can be written as 2 e square by 8 pi epsilon 0 here, that is 2 is multiplied in both numerator and denominator, then 5z by 4 into e square by 8 pi epsilon 0a. Now e square by 8 pi epsilon 0a is the ground state energy of hydrogen atom. Actually it is negative of the ground state energy of hydrogen atom, that is this is minus E1. That is E1 is equal to minus of e square by 8 pi epsilon 0a. So that becomes 2z square E1 minus, that is this term, e square by 8 pi epsilon 0a becomes minus E1. So this becomes minus 2z into 2, 4 minus 4z into z minus 2 E1 minus 5z by 4 E1. So that is equal to 2z square minus 4z square plus 8z minus 5z by 4 E1. That is equal to 2z square minus 4z square is minus 2z square, then adding these two we get plus 27 by 4z into E1. That is the expectation value of ground state energy, the expectation value of the energy or the expectation value of the Hamiltonian. Now to find the ground state energy, we are minimizing this energy in terms of the variation in the parameter z. That is, for getting E minimized, we put dE by dz equal to 0. And we will find a value for z. And using that value of z, we can find the minimum value of E. So dE by dz equal to 0 gives minus 4z plus 27 by 4 is equal to 0, or from which we get z is equal to 1.69. So actually the true value of, that is the original value of the atomic number of helium atom is 2, but the effective charge felt by one electron is less than 2. It is 1.69. So the remaining charge is screened by the next electron. So putting the value of Z is equal to 27 by 16 in equation 1, we get the minimum value of energy E0, that is minus 2 into Z square, that is 27 by 16 square, plus 27 by 4 into 27 by 16 into E1. That is equal to 3 raised to 6 by 2 raised to 7 into E1, where E1 is equal to minus 13.6. So we get 5.695 minus 13.6, or it will be minus 77.5 electron volt. So this is very close to the experimental value of minus 78.975 electron volts. So this is the result obtained by variational method. Now the same problem can also be done by using time independent perturbation theory. Here in the time independent perturbation theory, we will treat the Hamiltonian of the two independent electrons as the main Hamiltonian and the electron-electron interaction as the perturbation. So the unperturbed wave function will be the wave function of the hydrogen-like atom, size 0. So with respect to the unperturbed wave function, the energy E0 will be equal to 2Z square E1, that is equal to minus 109 electron volt, as already we have discussed. Now the first order correction to the energy is the expectation value of the perturbation with respect to the unperturbed wave function, that is 1 by 4 pi epsilon 0 E square into expectation value of this 1 by R1 minus 1 by R2, that is already discussed. It is 5Z by 8 A0, that is equal to minus 5 by 4 Z E1. Now the energy up to first order correction will be equal to the unperturbed energy plus the first order correction, that is 2Z square E1 minus 5 by 4 Z E1. Putting the value of Z is equal to 2, we get it is 5.5 E1, that is minus 74.8 electron volt. So this is also very close to the experimental value of minus 78, but the more accurate result is obtained by the variational technique. And this variational technique is applicable for two electron atoms like Li plus, Be2 plus, boron 3 plus, etc. with Z equal to 3, 4, 5, etc. That is, we have to provide the value of Z is equal to 3, 4, 5 here in this expression. So, thank you for watching this video.